The objective today, I can solve for pressure, volume, or temperature using the combined gas law. So a reminder that the combined gas law is pressure 1 times volume 1 divided by temperature 1 equals pressure 2 times volume 2 divided by temperature 2. Here are a couple of reminders of how to use the combined gas law. First, make sure we are familiar with all of our units. When you see atmospheres, millimeters of mercury, torr, or kilopascals, those are all units of pressure. If you see liters or milliliters, those are units of volume. And if you see degrees Celsius, it must be in Kelvin, so we're going to add 273 to turn it into Kelvin. Also, here is our equation for the combined gas law, and it is the P1 times V1 over T1 equals P2 times V2 over T2. A reminder, if you see STP, that's telling you two things. It's telling you you have a pressure equal to 1 atmosphere and you have a temperature equal to 273 Kelvin. So let's get started with our calculations. So first I'm going to write my equation. It is P1 V1 over T1 equals P2 V2 over T2. Now I'm going to read the problem and I'm going to label all of my variables. A gas at 155 kilopascals, kPa, that is a pressure, so this is pressure number 1. Here is our first temperature, 25 degrees Celsius. I'll label it T1, and because it is Celsius, I have to add 273 to change it to Kelvin. So we'll do that before we plug it into our equation. It has an initial volume of, so this is our V1. The pressure of the gas increases to, and here's our second pressure. So I'm going to call this P2. As the temperature is raised, so here's our T2, but it's in Celsius, so we have to add 273 to turn it into Kelvin. And then the question is, what is the new volume? So that means V2 is what I am solving for. That's going to be my X in this equation. So now I'm going to plug in the values that are provided for me. So the P1 is 155. My V1 is 1.00 liters divided by, and then my T1 is 25 plus 273, which equals 298 Kelvin. Equals, now plug in P2, which is 605 kilopascals. I don't know my V2, so I'm going to call that X over, and then my T2 is going to be 125 plus 273, which gives me 398. So now that I have all of my equations set up, I'm going to cross multiply to solve for X. You're not going to start your cross with the X. You want to start your cross opposite the X. And so what it's going to be is 155 times 1 times 398. And you see these guys that are associated with my X, I'm going to hit divided by 298 divided by 605. So in my calculator, I'm going to actually type it in exactly as I just read it to you. It's going to be 155 times 1 times 398. Then I'm going to hit divided by 298 divided by 605. And that's going to get us X equals 0.342. And whatever the volume is for V1, whatever the unit is for V1, which in this case was liters, that is also the unit of V2. So this answer is in liters. Number 2, we're going to use, first I'm going to write down my equation down below. P1 V1 over T1 equals P2 V2 over T2. Now, given the initial conditions, 760 millimeters of mercury, this is a pressure, so this is P1. 3.00 liters, that is my V1. And 273 Kelvin is my T1. Because it's already in Kelvin, I do not have to add 273. What will be the volume? So because that is the question, V2 is my X. So I'm going to circle it so I know that's what I'm solving for. If we increase the temperature to, so this is my T2, and if the pressure changes, and so this will be my P2. So now that I've identified everything, I'm going to just pull it down and put it in my equation in this order. So I'm going to put P1 first, which is 760 millimeters of mercury, times the V1, which is 3.00 liters, over the T1, which is 273 Kelvin. Again, because that's in Kelvin, I don't have to add 273. Equals, the P2 is 820 millimeters of mercury. The V2 is what I don't know, so that's my X. And then I'm going to put it all over my T2, which is in Kelvin already, so that's 298. So now we can do the math in our calculator. We're going to cross multiply. Don't cross here because the X is here. We're going to cross here. It's going to be 760 times 3.00 times 298. Then hit divided by 273 divided by 820. So we'll type that in. 760 times 3.00 times 298. And that's going to be divided by this 273 and then divided by this 820. And we get X is equal to 3.04. And that is a volume, V2. So whatever V1 is, that is the unit of my answer. Number 3, let's write our equation. P1V1 over T1 equals P2 V2 over T2. Now let's label our variables in the equation. 5.00 liters, that's my V1, the first volume I come to. Has a pressure of 107 kilopascals, that's going to be my P1. And it's at a temperature of 50 degrees Celsius. So this is my T1, but because it's in Celsius, we have to add 273 in order to change it to Kelvin. If the temperature is raised to, so this is going to be my T2, but it's in Celsius, so I'm going to add 273 to turn it into Kelvin. And the volume expands to 7.00 liters, that's my V2. What will be the new pressure? So P2 is our X. So now that I've identified all of my variables, let's plug everything into the equation. P1 is 107. V1 is 5.00 divided by T1. I'm going to have to add 50 plus 273, and that's going to give me 323 as the T1, equals P2 is what I don't know, so I'm going to put an X for P2. V2 is 7.00 all over, and then T2, I'm going to take my 102 and add 273, and that's going to give me 375 as my second temperature. So now that I have everything plugged into my equation, I can solve it. You're going to start your cross here. Don't cross there because that has your X. So it's going to be 107 times 5 times 375, and then we're going to hit divided by 323 divided by 7. So it's going to be 107 times 5.00 times 375, and then divided by 323, and then divided by 7.00. And we're going to get 88.7, so X equals 88.7. And then whatever pressure 1's unit was, pressure 1 was in kPa, that means that's what pressure 2 is. So I can put kPa as the unit on my answer. Our final example. First, I'm going to write my equation. P1 V1 over T1 equals P2 V2 over T2. So now let's identify our variables. A sample of sulfur dioxide occupies a volume of, this is V1, at 40 degrees Celsius. So this is T1, but it's in Celsius, so add 273 to make it Kelvin. 720 millimeters of mercury, that's going to be P1. What volume, that means V2 is my X, will the sulfur dioxide occupy at, and look here, at STP. When you see STP, that's telling you a temperature, which in this case our T2 is equal to 273 Kelvin, and our pressure, or in this case our P2, is equal to 1 atmosphere. Now, because this is in millimeters of mercury, I really want this pressure to also be millimeters of mercury. So if we look at our chart that will be given to us, 1 atmosphere is the same as 760 millimeters of mercury. Okay, so that one was a bit challenging to label everything, but now we can just plug in our numbers. So we're going to have 720 millimeters of mercury times my volume, 652 milliliters, divided by, I'm going to add 40 plus 273 to get my T1 of 313, equals P2 is 760 millimeters of mercury. I don't know V2 over, and my T2 is 273. So once I have all of that plugged in, now I can solve. We're going to start our cross here. It'll be 720 times 652 times 273 divided by 313 divided by 760. So we'll do 720 times 652 times 273 divided by 313 divided by 760, and we get 538.7. And then the units are going to be whatever V1's unit is, which is milliliter, is going to be V2's unit. So this answer is in milliliters.